Welcome to Cyborg 86. Miles is there busy working on the FMS Power Wagon, but we're going to do something else today while he's busy doing that. Today we're going to design and print a replacement gear and axle for this little RC car. This certainly isn't the hobby grade cars that I'm used to working on, but it was my grandson's toy and it broke almost immediately after he got it for Christmas. This will be the first time I've ever designed a gear. I'm no expert at this, but I did manage to get it done, and I'll show you what I did to get there. Maybe we can learn together. Oddly enough, designing the gear turned out to be the easy job. Getting this axle out of the wheel turned out to be the hard part. Finally, I just drilled the thing out of there. After that, getting the rest of it apart was just nice and easy. Finally, I got down to the offending gear and pulled it out, wondering why it broke so easy. But after I took the other gear off the other side for comparison, I realized that there was a pin missing. Somebody must have had a bad day at the factory. Fortunately, I had a little brass rod on hand that I had actually bought by mistake, and it fit perfect. Just need to cut it to size. Now that we know that's resolved, I can get to the point of making the gear. So I marked off how many teeth. I counted every 5 so I wouldn't lose track. Marked off the teeth, ended up with 35. Next I measured off the shaft and the diameter and things like that. Everything I needed to know to design new gear. After doing a little YouTube research, I jumped into Fusion 360. In there, there's a script you can run that'll create a gear for you. You just put in the parameters, number of teeth, mod, which would be the tooth size, things like that. And down at the bottom, you can see the resulting diameter of what you input. I was hoping to just put in the diameter and number of teeth and get a result that way, but that's not how it works. You put in the mod size. So I played with the mod size a little bit until the diameter that resulted at the bottom looked about right. The output looks like this. It looks to me like it's not extruded, but it is. I did go ahead and extrude here because I hadn't figured that out. But it does extrude automatically to the width that you put into the parameters, even though it doesn't look like it. So now it's time for a test print. We'll see how close we are. To save time, I just printed the gear and have not added the shaft yet. Wanted to see if it fit over the hole. It was a little bit tight, so I ended up adjusting. Also, you can see the gears aren't meshing here, so it needs a little bit bigger mod setting. So, back to Fusion 360. Since it's a script that runs, you can't just change the parameters and have it automatically modify. You have to actually delete it and run the script again with the new settings. No big deal, but it's a good idea to write your numbers down. It took me about 3 tries before I finally had a gear size and mesh that I was happy with. So now I'm adding a sketch on top of the gear, and I'm adding a circle for the outside of the shaft and another circle for the inside of the shaft, and that way I can extrude the hollow tube that way. The next part of the tube has a hexagon shape to it to keep it from spinning in the wheel. So I'll go ahead and use the polygon, adding a new sketch on top of the tube, and I input it wrong at first. When you add the tube, you put in the diameter, but on a polygon, you put in the radius. So that's why it looks twice as big at first. Took me a second to figure that out, and then we got it resolved. I went ahead and extruded this far enough with a larger center circle in it to make sure there was enough room for that brass axle to fit in there. Still not done yet. I need to add another section that has a smaller hole in the middle. That's so I can put the screw in to attach the wheel. It needs to be about 2 millimeters for the center hole, according to my estimate. So I'm going to go ahead and add that now. Now back to the slicer. I don't want to print the whole thing yet. I want to keep this moving along quickly. So what I'm going to do is cut off the top little piece and make sure two things. I want to make sure that the hole's the right size, and then also make sure that the hexagon area fits inside the wheel before I go printing the whole thing. And both the screw and the hexagon fit just like they're supposed to. So now I'm ready to go ahead and print. I'm going to switch from the PLA I've been using and go to PETG. I understand that's stronger and stiffer, so hopefully it'll hold up a little better. We'll find out. And now the moment of truth. Let's put the thing together and see if it fits and works. This looks very encouraging. If you've seen some of my prior videos, I've showed you how to do some modifications in a slicer. This one's a little more advanced than that, but really, I'm a layman. I've hardly done any of this type of work. I'm mainly showing this kind of video to give you a little encouragement. If you're a little intimidated by this CAD software called Fusion 360, by the way, it's free. They have a free version. That's how I can afford it. Anyway, if you're a little intimidated by that, don't be. I'm no expert, and I was able to get this done, and that's why I'm showing you this video. I would love to end this video by showing you this thing driving around, but I forgot to grab the battery charger from the grandkids. Yeah, it's definitely anticlimactic. All the gears moved freely and didn't make any noise when I turned it by hand, so we'll see if it holds up to some kids' hard use. In the future, we'll get back to the hobby grade crawlers like we're used to seeing, but I thought you might find this interesting. Happy crawling.
Well, are you happy? Are you feeling alright?